Hi, this is Bharat Burgojo. Today we're going to explain the assignment 9 reinforcement learning basic solution. Today I'm going to explain my understanding of this solution. So in this assignment we're going to learn some concepts like agent, environment, action, state, and observation and policy and rewards, uh, which are the definitions given in this assignment. So the main which we use here is agent, environment, action, and the rewards. So here the action states that which we have learned, which we given the inputs is like an actions given here. So here the observation is the information gathered by the agent from the state of an information. So and here we get a reward from a feedback which we given an input for the code. So here we get a signal from the environment to each action that the agent chooses to perform. Well, it is represented in a number for the scalar. So for the in this picturization, the actions which was given by an agent, the environment, we get an reverse observation and rewards or punishments from the environment which we given by the inputs. So we here this image is also called as RL pipeline. So for this, we'll be using an open AI gym. So here's a site. Okay. So this is an open AI gymnasium. So first we're gonna install the gymnasium, and we're gonna download the code reward uh, from for the callback. So and we're gonna import the library as a gymnasium as gym. So here the gym library contains many environments. So particularly we are using two classic control environments here. So one is cart pole. A cart pole is attached to a cart, so that moving along left or right to track a fictionless. And here the goal is to balance a pole standing on the cart, which was forcing left to right and right to left. We're gonna balance it on the a pole on the cardboard. So and the other one we are using is mountain car. So the car aim is to climb a car to the uh, flag. So the goal is to drive a car to reach the top of the hill. So which was given in a yellow mark flag. So to achieve that, we need to steer the car back or for back to gain enough mountain, or we wanna give some actions to the car to move back or left or climb the mountain or go back to the mountain. Here are the two uh, environments which we are using. So here is the cart pole, and here is the mountain car which we're gonna use in episode 1 and 2. So first of all, we're gonna create the environments to use this. So for the mountain car, we're gonna do the gym dot make of mountain car. So here the for the card pole, we're gonna make it as a gym dot make for the environment. So here we are creating the mountain. So here we are creating the environments and pulling out the environments which we are using in the code. So here the RL task is to design its own actions and observation and rewards. From this design, we these designs are very crucial for the success for this task. So here the cardpool of for the cardpool design and the elements which we have seen, which we can see in here. So here are the description for the cardpool. Yes. Here we are using ND array with the shape of 1 and taking the values of 0 and 1. Here we are taking the two iterations to push right or left, which to climb the mountain. So here we are taking a 0 to move left, and we are taking 1 to the right. And here we have an observation space, which is a cardboard position and card velocity and pole angle and pole angular velocity. Uh, so here are the descriptions, and we have a rewards, and we can end the state. So for this is a card pull description, and for the mountain car, we have a description here. So here's the mountain car description. Here we are using a three discrete values. For this, we gonna take the three description actions. We are giving a three input actions to remain same there itself. We gonna assign it as one, which means the car should not move. We are not giving the acceleration to the car, which means one, and we are giving zero the car to move left, and we are assigning a two value to the right, which the car moves right itself. So here are some dynamics and velocity, which for the position of the car, which we are giving here, and we are giving some range here minus 0.07 to 0.0 plus 0.07, and here the car position is clipped from the range of minus 1.2 and to 0.6. And here the goal is to reach the flag placed on the top of the right top. So here the learning agent is penalized with the reward of -1 for the time set. This is a description for the two cartpool and mountain. For this, we're gonna take two RL tasks before we proceed to this. And here, before that, we're gonna reset the environment for the getting start of this one. So here we are resetting the mountain car and cartpool environment, and printing the number of actions for the mountain, which is given for the two for the mountain, for the three for the mountain car and two for the cartpool, which was given here. The number of actions for the mountain car is 3, and which is 0, 1, 2, and for the cartpool, which is 0 and 1. So for here we are taking the first time step, which is called step function. The output which we include, the output includes is observation, reward, terminated, truncated, and the information, the additional information in the output. So for this, we're gonna explore some mountain car environment here. So we are taking a random action from the action space for the mountain car, which was code written as a random underscore action, which was given for the sample randomly. So the first step is mount the random action for the mountain car for 5, which is action and observation, reward, terminated, and truncated, which was given randomly. So I'm printing this input as action, and the remaining 4 will be observation, reward, terminated, and truncated are the outputs. Here we are giving two action to like two inputs, and we are getting a observation, reward, terminated, and truncated. So for this truncated and terminated, we getting false, and reward we are getting -1. So and the observation we are getting the range of 0.5 to 0 point some 0 decimal number, and the shape will be 2. So here for the exercise 1, we're gonna explore the cartpole environment here, and we're gonna perform like in a sequence. We're gonna perform the 10 actions linely, and 5 actions to move right, and then followed by the 5 actions move for the moving left. So here we have taken a sequence in an order of action, which was assigned as 1 1 1 1, which is moving to the right, and 5 zeros for moving to the left. So if the terminator we will be assigning as false, and we had using some while function, which for the action we are using some sequence linely as 10. So we're gonna print the action, observation, reward, and terminated and truncated. The action will be input, and the remaining 4 will be output. And the output will be the output return will be a size of limit in a text editor. So here we are getting a action. We are getting a 5 values uh, output, which was shown here. Uh, so we are getting a warning for the step function for the environment already have written will be terminated. So in the reinforcement learning task, we gonna sampling a random action. The learning agent will be get an action from the train policy, and we're gonna use the observation as an input here. So let's do this first, and in the first exercise, as we have reset the environment for the initial observations, and we're gonna do the same as itself now. Here we are taking the initial card pole observations and assigning as a card pole environment reset. So the same will be assigned for the mountain observations and printing the card pole observation and mountain car observations. And the shape will be given as the same which was given in the observations. So for the card pole observation, the range is minus 0.01 to 0.00, and the shape will be 4 for the card pole, and the mountain car observation the shape is 2, and we are getting a 0.4 minus 0.40 to 0. So here we are from the observation which we got from the output has a limits on how high and the low values which can be. So here we are printing the observation with the limits of card pole, for the maximum and minimum values. So as same as the mountain car, we gonna do the same for the mountain car, and we are getting the output after printing the executing the code. The observation, the highest maximum value we are getting is minus 4.80 to minus 4.41, and we are getting a 4 decimal points, and the minimum will be 4.8. It's a minus 4.8 to plus 4.8. So for the mountain car observation, limit will be maximum will be minus 1.2 minus 0.07, and the minimum will be 0.6 to 0.07. And here for the exercise 2, we are using Acrobat environment, which we are pulling from which before. So here for this Acrobat environment, we gonna how many action which we gonna use, and what are they and how will be they for perform. And the next step will be resetting the environment and the observation which we got, and what are the higher limits and the low or upper limits or higher limits from the observation which we got, and selecting a random action from a random space, and taking a step environment and rewarding it to how long will be take the action from the Acrobat environment. So first of all, the first step is to create the environment using a gym library. So the number of actions that can be taken here is printing a number of actions can be taken, which you have taken randomly. And after this, we gonna resetting the initial observation which we are taking, and printing the initial observations. And here we are observing the space and shape and limit for the Acrobat, and printing the values, for the maximum and minimum values. So here we are taking a random action. A random action will be assigned as an action space sample and for the randomly, and printing the random action taken here. And the fifth step will be taking a step for the environment and returning a reward which was after executing the code. And here we are using an giving as an input as an action, and returning the observation, reward, and terminator and truncated. So from randomly we are printing the reward, and we are getting the output as the number of taken as the number of actions we are giving is 3, which is 0, 1, 2. And here we the initial observation using array uh, we are getting a 6 decimal values, and here with the number of the limit which we got for the maximum and minimum will be -1 to 1, and we are taking the random action will be 1, and the reward which we got from the output is -1. So here, since the RL agent goal is to maximum the cumulative reward, and we are getting the reward as a feedback signal from the learning agent, and we'll be receiving the learning agent from the reward from the learning agent environment, Acrobat environment. And for the first thing, for the learning process of the agent is to plot a reward, and which we also known as learning curve. So here we are taking an example of this figure, which is DQN paper. The y-axis is on average score per episode and the training epochs. This is a y-axis showing for the reward gain from the x-axis of the training time. So okay, here we will not be using delve deep into the training for the learning agent. Instead, to show this, we're gonna train the agent using three baselines, which is the stable baselines, which was developed by the OpenAI, which was GIM, and we're gonna use some algorithms of the reinforcement learning. Here we gonna use the PPO algorithms to train the agent for the carpool and the mountain car environment. So for this, we're gonna install the stable baselines 3, and we're gonna install from okay, after installing, and we're gonna for the plotting function, we're gonna import OS and the numpy as NP, and we're gonna import the library from the Gymnasium as a gym, uh, which we're gonna import the discrete. So this is the given for the plotting function. Plot we're gonna import the matplot library from the plotting function. So after this, we're gonna create in case instance which will be restarting. So here we're gonna assign we'll be using a gym library for the assigning a carpool environment, and we are giving an action space for the environment for the discrete values. And here we gonna create a direction for the car which we gonna go to the right or left. Here, if the logic of the direction is true, we the logic of the regression which we has given is or 0 or 1. If it is true, the car will be moved for the true for the given. If it is 0, it moves to the left, and if it is 1, if it is true, it is moved to the right. So here we are using a creating environment for the monetization of the car, and we will be training some uh, training the uh, so here 20,000 time steps of the carpool environment which we gonna train per minute. So here we are defining a agent for the environment, which for the carpool, and we're gonna initiate the callback, which we return from the callback function, and training the carpool, and printing this function will be printing the agent. Printing the carpool of the agent, which we gonna get the total steps which we have taken in the 20 in a minute will be 20,000, and we are getting the executed reward after executing the code. So here we got an output of the size. We get a size of which we got a limit will be almost for 200 we got 20.25, and we have got some outputs here. Almost for the 20,400 we are getting a 200 episodes for the 89.63. uh, so here for the exercise 3, we're gonna use the Matplotlib library for the plotting function, which we got from the reward, and we are using the training during this code. So uh, and we have got a question for the reward, how much time the reward will be executed and will be written after executing the code. Here for the fetching data, we're gonna use two rows and just getting a reward. So here the reward data will be assigned as an NP of the array, uh, and we got giving a size of 0 to 1. Here we are here writing some plotting function which is a size of 10 to 5, and we are the length of x axis we gonna give it as a range of x and label as a reward. And for the plotting function, for this the reward series will be PD series of the reward data, and the plot of X will be labeled as a moving average, and the color will be red, and the title will be reward collected over 2 lakhs time steps, which we use in the plotting function. So as we have seen the curve from the starting to 0 to 300, as there's an increase in the graph. So here the dotted lines is a moving average, and the blue line is a reward which we got from the output. So here's the data of the collected reward over of 2 lakhs time lapses. Sorry, time steps. This is an example. So here the plot is greater than which the plot goes over the 3000 episodes. We specify 2 lakhs time step for the train, which the number of episodes to train. So here, to get that, we gonna evaluate the training agent, how good agents in a timely after training the data. So here we are rewarding over 100 episodes and evaluating the policy for the 100 episodes and observe the reward which we got from the execution. Here we are assigning the mean reward and standard award for the evaluate policy. Here we are giving 100 episodes for this and printing the values. For over the 100 episode for the training for the train policy in a carpool environment, we are getting a 500 output. uh, so in a main, the average of the observed expected from the train for the task has been solved. So, and here there's a bonus tip after installing some environments dependencies. So the video for the recording video, we gonna record which we gonna import some recorder from the libraries and writing a code for the video render. So for this we gonna take os.make irs and define a video render, and we are using while not terminated an action for the input and observation reward and terminated as an output, and returning a recorder environment. uh, for this render, we're gonna roll out and episode some environment to play. So for this we're gonna get the cartpool environment and agent for the cartpool will be getting after execution. So here for the building a video will be in the template of MP4 for the playing a video. So for the example will be shown here. So here is a performance of an agent of a cardboard during the training. So the pole is balanced on a cardboard. which we gonna write a code for not falling this pole down. So thank you.